Uh-oh. Uh-oh. Uh-oh.
Yeah,
I think, uh-oh.
Well, hello there. Welcome to another episode of Things That Should Probably Not Be 3D Printed. My name's Elliot. This is Revamped Outdoors. That's kind of what we do here. Today I'm going to go through how I designed up and printed and also tested an adapter that goes on your drill driver, aka battery operated drill. Here in the States, that's what we call them apparently. Drill driver sounds like something you install on your computer. To us, we don't quite understand it. But I'm going to go over what I did to design this adapter. All it does is chuck into your drill driver, the actual battery operated drill, and it allows you to turn an ice auger. An ice auger is just a big, like if you put in fence posts or anything in your life, you know these big augers, gas powered, drills down into the dirt. Same thing for ice fishing. We need to cut a hole in the ice to get to the fish. Some of those are electric, some of those are gas powered, and some of those have adapters that you can use on your drill. I should say that there are commercially available options for this. Clam makes one. There's a really popular Kovac one. These are normally milled out of metal, usually mild steel, and they couple up to the ice auger bit itself and then allow you to chuck it into a hand drill driver. I don't have a mill, and even if I did, I don't know how to run cam operations, but what I do know is how to run a 3D printer. So I've modeled it up in CAD using Fusion 360. We probably won't get real in depth about Fusion 360 in this video. I'll just show you kind of the design and what I did. And then I have some video testing it out, how it worked, and then we'll kind of recap it a little bit. So let's get into it by jumping into Fusion 360 first. Okay, so we're in Fusion 360 now here. If you're unfamiliar with Fusion 360, I won't really get into depth with that right here in this video, but I do have other videos that can familiarize yourself with Fusion 360, or else you can just do a quick Google search on it. It's a very powerful CAD software. If you're going to do anything that needs to be dimensionally accurate, it's really nice. It's also free to use if you're a hobbyist or you make under $100,000 a year, which obviously I qualify for. So I do use it for anything that's very specific measurements, stuff like this. So I'll go through it a little bit here. There's sketches. Those sketches, you revolve them, you push-pull them, you turn them into three-dimensional space. So we're not going to get into that, but what I will show you is kind of just my thought process on this. So the actual auger itself has a neck to it, and after you punch through the hole, I didn't want it to come out of the coupler of the drill driver and then go down the hole, right? Because you're using the auger bit to get through a hole. And if it comes out of the chuck of the drill, it just goes down. So what I did was made a small collar here. That's these two. I made the inside a separate color so you can see the distinction. So this inside collar then just bolts on to the shaft with just using M3 bolts. I think they're 20 millimeter M3 bolts. And then on the back side of this, you have places to put in a recessed hex nut, standard M3, so it sandwiches itself onto the main shaft. It's slightly smaller. I think it's like 0.4 millimeters smaller than the shaft itself, so it stays there. And then you have this outer collar that does the exact same thing, and this collar then allows it to spin as the auger is spinning with the drill driving it from the top. You put like a small bungee cord or something, or a rope over the top of it. That way, if this top portion of the chuck where you chuck it into the drill, if that comes loose, you don't lose your auger bit down. It actually holds on with a bungee cord over the top of the drill. So I think that helps out quite a lot. It also gives you a place of purchase to grab that auger after it comes out of the ice. That's just a simple set of revolves based on a two-dimensional sketch. So here's the sketch of that. I moved it down in space so you can see a little bit of a separation there. But that's all it is just a series of revolves and then push pulls, press pulls, and then cuts and all that sort of stuff. Kind of the fancier stuff you'll learn about if you look into Fusion 360. So then the business end, the part that's actually moving the auger bit itself, is up here on the top. So this screw pattern here is an M15 by 125. Seems to be a very uncommon thread pattern. I couldn't find it in any fasteners at all. All I could find was a tap and die set for it. And I didn't want to go through the hassle of trying to actually use the tap and die set and make my own, make a nut for it and then weld that to a new shaft or something. So we're using 3D printing here to kind of fill the gap in for unavailable parts. And in this case, the part itself is just going to be 100% printed in PETG, and it's fastened with 7 M3 bolts that come up to recessed fasteners to the nuts on top. So the bolts just come up through here. I think they're 25 millimeter or so to make up that difference. And then all this is just this thread pattern actually screws onto the auger bit itself, and then this cap comes over the top with the bolt inserted in the back, and I'll show you that. So you can see the bolt is just pushed in through, the head's recessed with very tight tolerance into the top portion. And what that does then is it gives it about 7 millimeters of 100% infill to block that rotation of that hex head. And then I also epoxy that in with like a quick set 1600 pound epoxy or something. It seems to help quite a bit. I've also shaved down the edges of this bolt into a triangular pattern so it can chuck into the drill a little bit easier and stays in a little bit tighter. Seems to work well. It centers up very well and it drives the auger straight and true. So that's all I'm kind of looking for with that section there. It is important to note that some of these augers, hand-driven augers that you can get for pretty cheap, the auger bit itself, if they're an older version, they're going to have this standard Mora thread on the top. If it's a blue Mora auger bit, there's a bunch of different companies that make different auger bits, but if it's an older version with the thread part, it doesn't matter what size the auger is. It could be 4 inches, 6, 4, 5, 6, 7, 8, 9, 10, 11, 12, whatever. They're all going to use that standard M15 by 125 thread. I'm thinking they use that just because then they can make one handle assembly and that's all they have to do. So that's just the basic principle of the whole thing. Pretty simple design. Seems to work well. It seems to be robust enough because it is 100% PETG. But what I've done is I've done some testing with it already, and we'll show a clip here in a second. But the idea is that we want to speed up the process because when you're using a hand crank auger, it's a lot of work, takes a lot of time, and anything that we can do to speed up the process, the better. Basic overview of augers. You can see on the tip here, there's just 2 blades. They go at a certain degree angle to shave the ice. So then this just goes through. As long as these stay sharp, it's usually pretty easy to get through. The hand crank just stays on top. Those threads onto a pitch thread diameter. I think they're M15 by 1.25. So this is just modeled out of PETG. I think this is Amazon Basics PETG, so pretty cheap, 13 bucks a roll. This is their blue. They have a 5-color pack that you can buy sometimes. So you can see it has this collar part that comes in 2 pieces, 1 and 2 printed. Then they get screwed together with some fasteners. So there's a spot on either collar that holds 2 M305 bolts, and they screw onto each other. So this is the inner collar, outer collar, and then this is just an adapter. It screws onto threads onto the top. We're going to power it with a 3/8 drill. These are made commercially, but they only work on a 1/2-inch drill chuck. So this one utilizes just a stainless steel 3/16 3/8 bolt with 16 pitch thread, stainless steel 2-inch, and then all I've done is just ground down 3 sides so it fits in the chuck a little bit better. So this is 100% infill on all these parts. I'll grab a bungee and put it over the drill just in case this fails. I don't want to lose my auger down in the ice. So we're going to try this, do 3 holes with this, and compare it to when I had to hand crank it. So
I hate hand cranks so much. It's not gonna be fun. Uh-oh.
So as you could tell by that video, my old Black & Decker 20 volt drill driver let the smoke out. It happens. I kind of knew it was coming. That thing's like 6 or 7 years old, and it's been given that good stink. After it gets a little torqued down, you can tell that the motor's getting a little bit shot on it anyway. So I was hoping to get a few more holes out of it, but I think for the purposes of this video, it shows that there is utility in 3D printed parts that you would think might not have the torque capabilities that you're hoping for. Because you can get these auger bits in larger sizes, I would think you'd probably want to stay in that 4-inch to 5-inch hole with a 3/8 drive drill driver, just because you're down in that lower torque range. I think that you could put this adapter on a larger drill bit, a larger auger bit, with a 1/2-inch chucked drill, because you're going to have that torque to move a larger auger bit. So we'll have to see. I'll play around with it. Been looking at a couple different sets of impact driver combos, because I do need to upgrade anyway. The good part about this is that I'll have 3 extra battery packs then to go into our community project for the wheelchair motor auger. Hopefully you enjoyed the video. If this is something you're into, kind of 3D printing outdoor equipment, lures, all that kind of stuff, please check my backlog on my channel. I got over 100 videos of different projects utilizing either 3D printing or some other mode of fabrication for the out of doors. If that's something you're into, please subscribe. If you like this video, make sure to like it. It's YouTube, you know how it goes. I have to say it. I will drop these STLs on Thingiverse, and you can pick up the STLs for free from there. If you don't have a 3D printer, they do have partnership programs. I've never personally used them, but you can get a 3D print on demand to send you something after you send them some money. So if that's something that you need to do, that option's always available. So yeah, hopefully you got something out of this. Hopefully you learned a little bit of something. Till the next one, keep your amps up and your filament dry.